Hey everyone, and welcome back for another deep dive. Today, we're going to be tackling something that's absolutely revolutionizing the tech world, and that is deep learning. Now, don't worry if you're not super familiar with this already. We'll be using a DataCamp tutorial that's specifically designed for beginners as our source material. So we're going to break it down together, promise.
Yeah, it's really a fascinating field. Deep learning is really making possible so many things that we used to think were only in science fiction.
Exactly. I mean, we're talking about self-driving cars that can navigate through traffic, AI that can create art that's selling for millions of dollars, and even algorithms that are beating professional gamers at their own games. To be honest, I'm a little bit mind-blown myself. I'm really excited to kind of get into the details.
Well, let's start by unraveling what deep learning actually is. So you've probably heard terms like artificial intelligence and machine learning kind of thrown around. Think of AI as the broadest concept. It's all about creating machines that can perform tasks that typically require human intelligence. Machine learning is a subset of AI where computers can learn from data without explicit programming. And deep learning, well, that's a specialized area within machine learning that's inspired by the structure of the human brain.
Okay, so it's all about mimicking how we learn. I'm intrigued. How does that work?
Well, think about how you learn to recognize a cat. You didn't memorize like a set of rules. You saw countless examples of cats, and your brain just figures out the patterns. Deep learning works in a similar way. So imagine showing a computer thousands of cat images. It uses something called artificial neural networks. These are layers upon layers of interconnected nodes that process information to identify the features that make a cat. Well, a cat. These features could be anything from the shape of their ears to the texture of their fur.
So instead of programming very specific rules, we're basically showing the computer a ton of examples and letting it kind of figure out the patterns on its own.
Exactly. The deep in deep learning actually refers to the multiple layers in these neural networks. The more layers there are, the more complex the patterns the model can learn. There's a helpful visual in the DataCamp tutorial called the similarity between neurons and neural networks that really brings this concept to life. And you can really see how these artificial networks are inspired by the structure of neurons in our own brains.
That's pretty amazing. But hasn't machine learning been around for a while? What makes deep learning so groundbreaking?
That's true. Machine learning has been around for a while, and it's revolutionized many industries. But traditional machine learning often requires a lot of manual effort. Let's take predicting the weather as an example. In traditional machine learning, a data scientist would have to carefully select the features that they think are important for making an accurate prediction. Things like temperature, humidity, wind speed. And then they would manually engineer these features from raw data, which can be super time-consuming and require a lot of expertise.
So what makes deep learning different? Does it eliminate that manual step?
Exactly. Deep learning models can automatically learn these features from raw data. It's like having a chef who not only cooks the meal, but also grows their own ingredients and preps them from scratch. This ability to automate feature engineering is a total game changer. It allows deep learning to handle massive amounts of data. We're talking like terabytes and petabytes, which would be literally impossible to process manually.
That makes a lot of sense. So deep learning can handle more data, can learn more complex patterns, and it can do it all with less human intervention. That's impressive, but why should we care? What impact is this actually having on our lives?
The impact is actually already immense, and it's only going to grow from here. Just look at the way that we interact with technology today. Facial recognition on our phones, personalized recommendations on streaming services, voice assistants like Siri and Alexa. These are all powered by deep learning algorithms. It's even revolutionizing fields like healthcare, finance, and transportation. Remember the visual AI versus ML versus DL from the tutorial? That really shows just how deep learning is already being used in this vast array of applications.
Okay, so it's already having a huge impact. This is all very exciting, but before we get too carried away, I want to understand the nuts and bolts a little bit better. How does a deep learning model actually learn? I mean, how does it go from a bunch of data to making accurate predictions?
That's a great question. It all comes down to something called feature extraction. So let's go back to our cat example. When you show a deep learning model thousands of cat images, it doesn't just memorize the pictures. It starts to identify the features that are common to all cats. It might learn that cats typically have pointed ears or a round face and a certain way of moving. These features are then used to distinguish cats from, say, dogs or birds.
So it's like the model is creating its own internal representation of what a cat looks like based on the patterns that it finds in the data.
Exactly. And this is where the structure of those neural networks we talked about comes into play. Remember how we said that these networks have multiple layers? Well, each layer extracts different levels of features. So the first layer might identify basic shapes like edges and curves. The next layer might combine those shapes to recognize eyes, noses, and mouths, and so on, until the final layer can confidently say, yes, this is a cat.
That's fascinating. It's like the model is building this hierarchy of understanding from simple shapes to complex concepts.
Exactly. The visual simple neural network in the tutorial is a great way to visualize this whole process. You can see how information flows through the layers, from the raw data input to the final output. It really helps to demystify how these models work.
This is all starting to make sense. So we've covered what deep learning is, how it evolved from traditional machine learning, and how it leverages neural networks to extract features and make predictions. But I'm dying to hear more about those real-world applications that you mentioned. What are some of the most impactful examples?
But one area that's seen a lot of progress is computer vision. Um, Things self-driving cars, facial recognition, and even medical imaging analysis. For example, the tutorial mentions how deep learning is being used to detect anomalies in medical images, which could potentially help doctors diagnose diseases earlier and more accurately.
Wow, that's incredible. It sounds like deep learning is already having a pretty profound impact on healthcare.
Absolutely. And we're really just scratching the surface. Let's talk about another fascinating application, something called generative AI.
Oh yeah, I've heard about this. Isn't that where AI is creating art and music and even writing code?
That's right. Generative AI is all about AI creating new content, and it's really pushing the boundaries of what's possible. Remember those CryptoPunk NFTs that were selling for millions of dollars? Those were generated using a deep learning model called a GAN, or a generative adversarial network.
Wait, so AI is now creating art that's considered valuable enough to sell for millions of dollars. That's wild.
It is, and that's just one example. We're also seeing AI writing novels, composing music, and even generating realistic human faces that don't actually exist. The generative art visual from the tutorial captures some of these amazing things that are being created with generative AI. It's really a field that's exploding with creativity.
This is mind-blowing. So we've got AI driving cars, analyzing medical images, creating art. What else is it capable of?
Well, those are just a few examples. There's a whole world of applications out there. From language translation to fraud detection to personalized medicine, it's truly a transformative technology that's changing the way we live and work. But before we dive into more of these applications, I think it's important to understand some of the core concepts that make deep learning tick. Things like activation functions, loss functions, and backpropagation. These are the building blocks that allow these models to learn and make accurate predictions.
You're right. Let's dig a little bit deeper into the inner workings of these models. Tell me more about these activation functions. What role do they play?
Activation functions are kind of like the decision makers within a neural network. They determine whether a neuron should be activated or not based on the input that it receives. Think of it like a light switch. If the input is strong enough, the light turns on. If not, it stays off.
So it's a way for the network to filter information and decide what's important.
Exactly. And there are different types of activation functions, each with its own unique characteristics. The visual activation function in the tutorial shows how these functions work and how they can impact the output of a neural network. It's like having different types of light switches that control different parts of the network.
Okay, so activation functions are the decision makers. What about these loss functions? What do they do?
Loss functions are how a deep learning model measures its own performance. They quantify the difference between the model's predictions and the actual values. It's like a feedback mechanism that tells the model, hey, you're a bit off here, you need to adjust your weights.
So it's like a coach telling an athlete how to improve their technique.
That's a great analogy. And just like a coach helps an athlete refine their technique, the loss function helps the deep learning model improve its predictions.
This is fascinating. So we have activation functions making decisions and loss functions providing feedback. But how does the model actually learn from its mistakes? That's where backpropagation comes in, right?
You got it. Backpropagation is the process by which the model learns from its errors and adjusts its weights to improve its performance. It involves going back through the layers of the network, tweaking the connections between neurons, and trying to minimize that loss. It's like fine-tuning a musical instrument to get the perfect sound.
So activation functions are the decision makers, loss functions provide feedback, and backpropagation kind of fine-tunes the whole system. This is starting to feel like a well-oiled machine, but I'm guessing there are different types of machines, right? What are some of the different deep learning models out there?
You're absolutely right. There are different types of deep learning models, each suited for different tasks and data types. The tutorial breaks them down into three main categories: supervised learning, unsupervised learning, and reinforcement learning.
Okay, let's dive into those. What's the key difference between supervised and unsupervised learning?
In supervised learning, you provide the model with labeled data. That means each data point comes with a corresponding output or label. Think of it like teaching a child to recognize different fruits by showing them pictures and telling them, this is an apple, this is a banana, this is an orange. The model then learns to map inputs to outputs based on these examples. Supervised learning is used for tasks like image classification, where you want to categorize images, or regression, where you want to predict a continuous value, like the price of a house.
So supervised learning is like having a teacher kind of guiding the model. What about unsupervised learning? What happens when there's no teacher?
Unsupervised learning is all about finding patterns in data without explicit labels. It's like giving a child a pile of Legos of different shapes and colors and letting them figure out how to group them together based on similarities. The model has to discover the underlying structure in the data on its own.
Interesting. So it's more about exploration and discovery. What kind of tasks is unsupervised learning good for?
Unsupervised learning excels at tasks like clustering, where you want to group similar data points together. For example, it's used to group customers with similar buying habits, identify different species of plants, or even detect anomalies in financial transactions.
That's really cool. And then there's reinforcement learning, right? We talked about that a little bit earlier with the AI playing video games. What's the gist of that one?
Reinforcement learning is all about learning through trial and error. Remember that Mario example? The AI agent, in this case Mario, interacts with the environment, taking actions and receiving rewards for successful outcomes. Over time, the agent learns to maximize its rewards by choosing the best actions in each situation.
Okay, I'm starting to see the difference. So supervised learning is like having a teacher, unsupervised learning is like being a detective, and reinforcement learning is like training a pet with rewards. But are there other types of models beyond these three?
There are. The tutorial also mentions some more specialized models, like generative adversarial networks, or GANs, and graph neural networks, or GNNs.
Ooh, those sound intriguing. What makes them unique?
GANs, as we mentioned earlier, are used for generating synthetic data, like those CryptoPunk NFTs. They involve two neural networks competing against each other, one trying to generate realistic data and the other trying to distinguish real from fake. It's like a constant game of cat and mouse that leads to both networks getting better and better over time.
Wow, that's a fascinating concept. And what about these graph neural networks? What are those used for?
GNNs are a bit more specialized. They're designed to operate on data that has a graph structure, meaning data that's represented as nodes and edges, like social networks or molecular structures. They excel at tasks like node classification, link prediction, and clustering. And they're being used in fields like social media analysis, drug discovery, and recommendation systems.
Okay, so GNs are like creative artists, and GNNs are like social butterflies understanding relationships. This is all very cool, but I have to admit I'm feeling a little overwhelmed by all these different types of models.
I understand. It is a lot to take in. But the key takeaway is that deep learning is a vast and rapidly evolving field with a wide range of applications. The type of model that you choose really depends on the specific problem that you're trying to solve and the nature of your data.
That makes sense. So how do people actually build these models? Are there specific tools and frameworks that they use?
Absolutely. There are several popular deep learning frameworks out there that provide the building blocks for creating these models.
Like what?
The tutorial mentions three of the most popular ones: TensorFlow, Keras, and PyTorch.
Okay, let's unpack those. What are the key differences between them?
TensorFlow was developed by Google, and it's widely considered the industry standard. It's a really powerful and comprehensive framework that supports a variety of hardware platforms, making it suitable for both research and production-level deployments.
So TensorFlow is like the heavy-duty toolkit for professional deep learning engineers. What about Keras?
Keras is known for its user-friendliness and ease of use. It runs on top of other frameworks like TensorFlow and provides a higher-level interface that simplifies the process of building and experimenting with deep learning models. It's a great choice for beginners and for rapid prototyping.
So Keras is like the beginner-friendly toolkit making deep learning more accessible. What about PyTorch?
PyTorch is popular for its flexibility and its research-oriented focus. It's widely used in academia and research labs due to its intuitive design and efficient handling of tensors, which are the building blocks of deep learning models.
Okay, so TensorFlow for the pros, Keras for the beginners, and PyTorch for the researchers. That's a helpful overview of the deep learning framework landscape. But before we move on to part two, I want to just take a moment to appreciate how much we've covered already. We've gone from the basics of deep learning to the intricacies of different model types and frameworks. It's impressive how much information is packed into this single tutorial.
It's true. This DataCamp tutorial does an excellent job of introducing the key concepts of deep learning in a very clear and accessible way.
I couldn't agree more. This deep dive has been an incredible journey so far, and I'm eager to explore more of these real-world applications in part 2.
Me too. There's so many exciting things happening in the world of deep learning, and I can't wait to share some of those with you. Welcome back, everyone. Before the break, we were talking about the wide range of deep learning applications, and I'm eager to dig into some more fascinating examples.
Me too. I'm particularly intrigued by this concept of computer vision. It sounds like something straight out of a sci-fi movie.
It does, doesn't it?
Yeah.
But the reality is that computer vision is already all around us. Think about facial recognition on your smartphone. That's computer vision in action, using deep learning to analyze images and identify individuals.
Right, I use that all the time to unlock my phone. But the tutorial mentioned something even more mind-blowing. Self-driving cars.
Exactly. Self-driving cars rely heavily on computer vision to perceive their surroundings, detect objects, and navigate safely. It's a complex task that involves analyzing real-time video feeds from multiple cameras and making split-second decisions.
That's incredible. So deep learning is essentially giving these cars the ability to see the world.
That's a great way to put it, and it's not just about identifying objects. These models can also estimate distances, predict trajectories, and even understand the context of a scene. The face recognition visual from the tutorial gives a glimpse into how these models work, showing how they can identify key features to distinguish between different faces.
It's amazing to think how far we've come. But what about other areas of computer vision? Does the tutorial mention any other interesting examples?
It does. It talks about how deep learning is being used in medical imaging analysis, which has the potential to revolutionize healthcare. Imagine algorithms that can detect subtle anomalies in X-rays or MRI scans that might be missed by the human eye.
That's incredible. It sounds like deep learning could help doctors diagnose diseases earlier and more accurately.
Precisely. And it's not just about detection. These models can also help doctors personalize treatment plans and predict patient outcomes. The possibilities are really exciting.
It sounds like deep learning is already making a huge impact on healthcare. What other fields are being transformed by this technology?
Well, we talked about generative AI earlier, and that's a field that's really exploding with creativity. But beyond art and music, deep learning is also transforming how we interact with language. Think about automatic speech recognition, which powers voice assistants like Siri and Alexa.
Oh, yeah. Those have become incredibly good at understanding what we say.
They have. Deep learning has enabled these systems to recognize speech patterns, filter out background noise, and even understand different accents. It's fascinating to see how these models are bridging the gap between human language and computer understanding. The speech pattern recognition, visual from the tutorial, gives a good overview of how this works. It shows how the model analyzes audio signals, breaks them down into phonemes, and then converts those phones into text.
It's amazing how these models can make sense of something as complex and nuanced as human speech. But isn't language translation another area where deep learning is having a big impact?
Absolutely. Deep learning has revolutionized language translation, making it faster, more accurate, and more accessible than ever before. Think about the ability to instantly translate web pages, documents, and even conversations in real time. It's breaking down language barriers and connecting people across the globe.
That's incredible. But the tutorial hints that deep learning goes beyond just translating between languages. What else can it do?
It's true. Deep learning is being used to translate not just words, but also concepts and ideas. For example, researchers are using it to translate molecular structures into chemical formulas, or even mathematical equations into different notations.
Wow, that's mind-blowing. So we're not just talking about translating languages anymore, but also translating between different domains of knowledge.
Exactly. And the language translation visual from the tutorial captures this idea perfectly. It shows how deep learning can be used to bridge the gap between different forms of representation, opening up new possibilities for scientific discovery and collaboration.
This is all so fascinating. But what about the world of finance? Is deep learning making an impact there too? Absolutely. Deep learning is being used by financial institutions to detect fraud, assess risk, and make investment decisions. It's also being used to personalize financial advice and automate trading strategies.
That makes sense. There's so much data in the financial world. Stock prices, transaction histories, economic indicators, and deep learning models are perfect for analyzing all that data and identifying patterns that humans might miss.
Exactly, and those patterns can be incredibly valuable for making informed financial decisions.
This is starting to feel like deep learning is impacting almost every aspect of our
It
lives.
is, and it's not just about analyzing existing data. Deep learning is also being used to predict future trends.
Mm.
Think about time series forecasting, which is used to predict things like stock prices, weather patterns, and even the spread of diseases.
So we're talking about AI predicting the future. That sounds a bit sci-fi, but also incredibly powerful.
It is powerful. These models can analyze historical data, identify trends, and extrapolate those trends into the future. The time series forecast visual from the tutorial shows how this works. It's like having a crystal ball, but one that's based on data and algorithms rather than magic.
That's incredible. But what about the physical world? Can deep learning be used to control machines and robots?
Absolutely. We touched on this earlier with self-driving cars, but deep learning is also being used to control robots in manufacturing, logistics, and even healthcare. The robotic arm powered by reinforcement learning, visual, shows a great example of this.
Wow, that's impressive. What other kinds of things are these robots doing?
They're doing everything from assembling products in factories to assisting surgeons in operating rooms. Remember, we discussed reinforcement learning. Well, that's a key technique used to train robots to perform complex tasks.
So it's like teaching a dog new tricks, but with robots instead of pets.
That's a great analogy. And just like a dog learns to perform tricks to get rewards, these robots learn to perform tasks by receiving positive reinforcement for successful outcomes. It's a powerful technique that's enabling robots to become more intelligent and autonomous.
This is mind-blowing. So deep learning is not just about analyzing data and making predictions. It's also about controlling machines and shaping the physical world around us.
Exactly. And it's even being used to improve customer experiences. Think about chatbots, which are becoming increasingly common in customer service.
Oh, yeah, I've definitely encountered those. They're getting surprisingly good at understanding my questions and providing helpful responses.
Deep learning is enabling these chatbots to understand natural language, identify customer intent, and even personalize their responses. The customer feedback visual shows an example of how this works.
It's amazing to think how deep learning is impacting so many different areas of our lives. From self-driving cars to medical diagnoses to customer service, it's everywhere. But the tutorial also mentions some ethical considerations that come with this powerful technology. What are some of those?
That's an important point. While deep learning has immense potential for good, it's crucial to use it responsibly. For example, we need to be mindful of potential biases in the data that these models are trained on. If the data reflects existing societal biases, the models might perpetuate those biases, leading to unfair or discriminatory outcomes.
That's a crucial point. So it's not just about the technology itself, but also about how we develop and deploy it.
Exactly. We need to ensure that these models are fair, transparent, and accountable.
This has been an incredible exploration of the applications of deep learning. From healthcare to finance to robotics, it's clear that this technology is having a profound impact on our world. But I'm curious what's next for deep learning. What are some of the emerging trends and future possibilities?
That's a great question and a perfect segue into our next segment. Stay tuned, because in Part 3 we'll delve into the future of deep learning, exploring the frontiers of this rapidly evolving field and the potential impact it could have on our lives.
Welcome back to our deep dive into the world of deep learning. So far, we've covered the basics, explored how these models work, and even taken a whirlwind tour of some of the most exciting applications. But what's next? Where is this technology headed?
That's the question on everyone's mind, right? Deep learning is still a relatively young field, but it's evolving at an incredible pace. It's like watching a rocket take off. It's going somewhere amazing, but you can't quite predict the exact trajectory.
That's a great analogy.
Yeah.
So what are some of the areas where you see the most potential for growth and innovation?
One area that's really heating up is the intersection of deep learning and natural language processing, or NLP. We talked about how deep learning is powering things like voice assistance and language translation, but it's going even further. Imagine AI systems that can not only understand language, but also reason, learn, and even generate creative content like poems, scripts, and even code.
That's incredible. So we're talking about AI that can not only mimic human language, but also think and create like us.
Exactly. The tutorial mentions this concept of transfer learning, which is a game changer for NLP. It's like giving a student a solid foundation in a subject before they specialize in a particular area by training a model on a massive data set of text and code. Researchers can then fine-tune it for specific tasks like writing different kinds of creative content or even generating new scientific hypotheses.
Wow, that's fascinating. So it's like giving AI a crash course in human knowledge and then letting it loose to explore new frontiers.
That's a great way to put it, and the potential applications are mind-boggling. Imagine AI systems that can help us write better novels, compose more beautiful music, or even discover new scientific breakthroughs. It's a world where human creativity and AI ingenuity can work together to push the boundaries of what's possible.
This is starting to feel like something out of a science fiction novel, but it's happening right now. What other areas are you excited about?
Another area that's full of potential is the development of more efficient and robust deep learning models right now. Training these models can require massive amounts of data and computing power, which can be expensive and time-consuming. But researchers are developing new techniques that can train models with less data and fewer resources, making deep learning more accessible to a wider range of users.
That makes sense. If we can make deep learning more efficient, it opens up a whole world of possibilities for smaller companies, researchers, and even individuals to leverage this powerful technology.
Exactly. And it also makes deep learning more sustainable from an environmental standpoint. Training these massive models can have a significant carbon footprint, so finding ways to reduce that impact is crucial.
That's a great point. So we've got AI that can understand and generate language. We've got more efficient and sustainable models. What else is on the horizon?
Well, one of the most exciting areas is the development of new hardware, specifically designed for deep learning. We talked about frameworks like TensorFlow and PyTorch, but those frameworks run on general-purpose hardware like CPUs and GPUs. But now, companies are developing specialized hardware like Google's TPUs or tensor processing units that are optimized for the unique demands of deep learning.
So it's like having a car engine specifically designed for racing. It's going to perform much better than a general-purpose engine on the racetrack.
That's a perfect analogy. These specialized chips can process information much faster and more efficiently, which means we can train larger and more complex models, leading to even more groundbreaking applications.
This is incredible. It feels like we're on the cusp of a new era of computing where deep learning is at the forefront.
It does, doesn't it? And as this technology continues to evolve, it's going to have a profound impact on every aspect of our lives, from the way we work to the way we interact with the world around us.
This deep dive has been an incredible journey, and I feel like I've only scratched the surface of what deep learning is capable of. But one thing is for sure, it's a field that's full of potential and promises to reshape the future in ways we can only begin to imagine.
I couldn't agree more. It's a field that demands curiosity, creativity, and a willingness to embrace the unknown. And as we've seen, it's a field that's already delivering on its promise, pushing the boundaries of what's possible, and opening up new frontiers of human ingenuity.
This has been an eye-opening experience, and I want to thank you for sharing your expertise with us today.
Mm-hmm.
It's clear that you're passionate about this field, and your enthusiasm is contagious.
The pleasure was all mine. I'm always excited to talk about deep learning, and I hope this deep dive has inspired you to explore this fascinating field further.
It definitely has, and to all of you listening, thank you for joining us on this journey into the world of deep learning. We hope you found it as enlightening and thought-provoking as we did. Until next time, keep exploring, keep learning, and keep asking